Welcome to qnawire.
Okay, so we are being asked to find intervals on which f is increasing, decreasing, the local min and max, and the intervals of concavity for f of x. So in order to first find where the function is increasing or decreasing, we apply the first derivative test. We have to take the derivative. So this will come out to be 2x minus 1 minus 1 over x. And then what we are going to do is we're going to factor out a 1 over x in this case. So we factor out a 1 over x, so that means this 2x will now become 2x squared, so that it remains 2x. And then this is going to become minus x, and this can become minus 1. And then now we can actually factor the inside term, and this will come out to be 1 over x, and this factors into 2x plus 1, and x minus 1. And we set this equal to 0. And at our convenience, this is a lot easier to solve for 0. So we know that 1 over x, there's no point in which that equals 0. And 2x plus 1 equals 0 at x equals negative 1/2. And x minus 1 at 1. However, since our domain of this function due to ln of x is all x greater than 0, we don't include negative 1/2. So now all we have to do is create a sign chart to see where our function is increasing or decreasing. Since 1 over x is always positive, because we're on domain of x greater than 0, we can ignore that case. So we'll bring up 2x plus 1 and x minus 1. And we're going to do it from 0 and 1. We ignore everything less than 0 because the domain, again, is greater than 0. Bring a line across. So for 2x plus 1, it's all positive. And then for x minus 1, a number between 0 and 1 gives a negative, and this gives a positive. You multiply these together, we get the sign of f prime. This gives us negative, this gives us positive. Now we know where it is increasing or decreasing due to the sign. So it is increasing on 1 to infinity. And then we know it is decreasing from between 0 and 1. And since we know the way it is increasing and decreasing, we know the local max and min. Since it is decreasing and then increasing, we know that there's a local min. So local min occurs at x equals 1, and there is no local max. And for concavity, we have to take the second derivative. The second derivative is 2 plus 1 over x squared. So we 2 plus 1 over x squared. And we do the same thing. We set this equal to 0. However, as you see that this can never equal 0. So we have to look at whether this is positive or negative. So this is never the case. If you look at this, since our domain is x greater than 0, we know that f prime has to be positive. So since f double prime is positive, we know that it is concave up everywhere on its domain. So concave up on 0 to infinity, which is its domain. And since there's no change in sign, there is no inflection point. No inflection point. And that is all.